Okay, today we're going to be doing Module 5, Lesson 13, where we're going to multiply mixed number factors and relate to the distributive property in the area model. So we've been working on finding the area of rectangles, specifically using the area model and the distributive property, because those go hand in hand. I'm going to go over another way of multiplying fractions with you today, and it should be somewhat of a review, because I know we talked about this during Module 4, but we never did with such big numbers. So from our fraction knowledge, we know that we can write fractions in many ways. So we can have like a basic fraction. We can have what we call a mixed number, where it's a whole number and a fraction. And then we can also have fractions where we call them fractions greater than 1, where the numerator is bigger than the denominator. So something like 8 over 2 or 16 over 4. Anytime the numerator is bigger than the denominator, we call them fractions greater than 1 because they are bigger than 1. I can take multiple 4s out of this 16 or multiple 2s out of this 8. And we can go back and forth from a mixed number to a fraction greater than 1. So for example, if I had the fraction 1 1/3, I can write that as a fraction greater than 1 because I can think of this 1 as 3 over 3. And then I have 3 over 3 plus 1 over 3, and I get 4 over 3. And then I can also think of it like, let's say I had something like this, 2 4/5. I can again write this as a fraction greater than 1 by knowing that that 2 is really 5/5 and 5/5. And so 5 plus 5/5, it's hard for me to say, 5/5 plus 5/5 plus 4/5 is going to give me 14/5. We also learned that there is a quick way of doing this multiplication wise to help us, especially as our fractions get bigger and bigger. Because what we basically did is we knew that there were 2 copies of 5/5, so we can do 5 times 2, which gives us 10, which is these right here, 10. And then we can add the numerator, which is the 4. So 10 plus 4 is 14/5. So if I have the fraction 1 3/4, I can do 4 times 1 plus 3. So 4 times 1 is 4, plus 3 is 7. So 1 3/4 equals 7/4. Or if I had like a big fraction, like 15 1/2, same rules apply. And this is a good strategy to know so I don't have to do 15 copies of 2 over 2. I can do 1/2. And I can do 2 times 15 is 30. Plus 1 is 31 halves. So it's just a quick way of going from a mixed number to a fraction greater than 1. And this is going to come in handy as we multiply today, because we are going to multiply using this new fraction greater than 1 method. Now we can draw area models still as a way to multiply 2 fractions and a way to find areas of mixed numbers, but we're going to practice this fraction greater than 1 today to see if it's a strategy that you like. So we've got this first one, 8/3 times 24/4. And we're trying to find the area of this rectangle. Now they already did the hard work for us here. They already took their mixed numbers and then turned them into fractions greater than 1. 8 over 3 is a fraction greater than 1, and so is 24 over 4. So all we need to do is just multiply and treat them as regular fractions. Because once we turn a mixed number into a fraction greater than 1, we just have 2 standard fractions. So we have 8/3 times 24/4. The denominators is easier for me. 3 times 4 is 12. The numerators I'm going to have to do off to the side. So it's just 24 times 8. 4 times 8 is 32. 16, 19. So 192/12. Well, going from a fraction greater than 1 to a mixed number, all I do is division. So 192 divided by 12. 12 goes into 72 6 times. That goes in nicely. So my answer is just 16 square centimeters. Now, you can see here why sometimes doing the fraction greater than 1 method can be a little harder in certain cases because it gives you larger numbers to work with. Like 24/8, I can't do that math in my head. So I have to use scratch paper to do that big multiplication to get 192. And then again, this simplifying of 192 divided by 12, I can't do that in my head. So I have to do the big division. So you'll notice that when you're solving multiplication, where you're deciding whether to do the distributive property or to turn them into fractions greater than 1, sometimes you're going to want to go one way and other times you're going to want to go the other way based off of what the multiplication and division is going to give you. Okay, so let's look at C. 5 4/6 inches times 4 3/5 inches. Now we're going to practice this again using the fraction greater than 1 so we can practice that skill. I have two mixed numbers. I want to write them as fractions greater than 1. So 5 4/6, I can do 6 times 5 is 30, plus 4 is 34/6. My denominator stays the same. And we're going to times that by 5 times 4 is 20, plus 3 is 23/5. So 34/6 times 23/5. I'm already looking at these numerators. So I know my denominator is going to be 30. My numerator, I'm going to do 34 times 23. So 782 30ths. Again, I have to simplify that because that numerator is bigger than that denominator. I know a fraction bar is a division sign, so I can do 782 divided by 30. 30 can go into 7 no times. 30 can go into 78 2 times. 30 into 182. I can think of that as like a 3 and an 18. So that should be able to go in 6 times. Because 6 times 30 is 180. And I get 2 as a remainder. No more numbers to bring down. I'm going to keep this as a fractional answer because I'm dealing with fractions. So I'm going to do 26 2 30ths. 26 2 30ths. General rule of thumb is whatever type of number we start with is what we want to end with unless they ask otherwise. So because they gave us fractions to start with, we want our answer to be in fractions. So this is 26 2 30th square inches. I see this 2 over this 30 and I know I can simplify that and divide it each by 2. So I can write it as 26 1/15 square inches. So doing it where it's fraction greater than 1 and we're multiplying it straight across, you end up doing less operations. Like I only did 1 multiplication. I technically did 2. And then 1 division versus if I was going to do this in the partial product way or the area model way, I would have to done 4 operations. But there's give and take because this I had to do all on paper. And if I did it partial product, I could probably do most of those equations in my head. The last question we're going to look at is question number 3, and we're not going to finish this in completion, but I do want us to talk about problem solving. So question number 3 says, a hotel is recarpeting a section of the lobby. Carpet covers the part of the floor shown below in gray. How many square feet of carpeting will be needed? So looking at this picture, the carpet is gray and the white is, I don't know, furniture of some kind, tile. I don't know, it doesn't need to be carpeted. So I need to figure out the area of just the gray part. And so I know I can do that by using some subtraction because they give me the dimensions of the entire rectangle, the whole room, as 19.5 by 31 7/8. So if I do that, 19.5 times 31 7/8, this will give me the area of the entire room. I'm going to say this is the area of the whole room. And then I don't need carpet in the whole room though. I don't need any of that white space. So I want to figure out a way to subtract that white space out of the area of the whole room. Looking at this white space, I can kind of see this is 3 separate rectangles. So we can call this like A, B, and C. And once I break them apart, I think I can figure out the area of each rectangle and then subtract that area from the total. So if I think about what I need to subtract, I can say, okay, area A is 13 3/5, because it's this right here, times this. So 11 3/4. So that'd be the area of A. And then B, so it's 3 3/4 times 12. I appreciate how they have everything labeled for me. And then C is 17, so that's this length, by 2.5. So if I do all of this math for A, B, and C, that would give me the areas of these 3 white rectangles. And then I can take those separate areas and subtract them from the area of the room. So I can find out this. So it can be the area of the room minus area of A, area B, and area C. And you can do this where you add them all together to find the total white area and then subtract that one time from the gray area. Or you can do multiple subtractions. We're not actually going to go through and solve all of these problems right now, but I did want to show you a general gist of how you can do this where you're trying to figure out the area of the space around something. We do that via subtraction. So hopefully this was a good little introduction on how we can use another strategy to multiply our fractions together, turning them into single fractions or fractions greater than 1, and then we multiply straight across.